Hi, Rebecca here. I'm making this video to primarily address the no warming since 1998 argument, and I'm going to hope to show you guys some statistics along the way. It's going to be pretty basic, so if you're familiar with basic statistics, maybe you've done it in college with your science degree or whatever, this might be a little bit boring for you. But I'm going to show you a little analysis I did, and it's inspired actually by Tamino. I don't know if you know his blog. If you know his blog, well done. If you don't, check it out. That's it on the page right now. And I guess I'll get on with the video now. So I took a slightly different approach to statistical analysis here. I wanted to have results that were perhaps more intuitive for people without any statistical training to understand. And hopefully this will give some of you the tools you need to have an analytical look at some of this data by yourself. So I examined the four major temperature series, that's global temperatures, GISS, UAH, HAD-CRU and RSS, and I decided to investigate just how common the trend since 1998 in each series would actually be, using artificial data which was created using parameters from the real data. That will become more apparent later if you don't understand what I mean. But first, a good place to actually start would be to look at the data and see if the trend since 1998 is actually unprecedented or not in the current warming period, which is from about 1975. So here we are, GISS data. We can see that from 1998 to 2010 the trend was 0.014 degrees per year, and if we look back for another 13-year trend which matches that or is less than that from 1975, we find that 81 to 93 is 0.0075 degrees per year. So of course if global warming stopped in 1998, then it stopped twice as hard in 81. And here we have the University of Alabama Huntsville data. You can see the trend from 98 to 2010 is 0.007 degrees per year, whereas 80 to 92 is 0.001 degrees per year, meaning that global warming stopped 7 times as hard in 1980 as it did in 98. Joking aside though, I am going to be an honest investigator and admit that there is no precedent for the trend from 1998 in the HAD-CRU data or the RSS data, and you can actually see this in the end analysis I will show you in a minute. So finally into the nitty gritty, here we go. How did I do what I done? So I'm just going to use the GISS data to show you my methodology. And first of all we need a trend to create our artificial data. In the GISS data, since 1975 we have a trend of 0.018 degrees per year. And the second measure we need is the standard deviation. It sounds technical, but it's really nothing to be scared of. It's just a measure of how variable the data is. And here is your formula for standard deviation. I'm just going to quickly explain what all this means. It's not too difficult. The x with the bar is the average of your data. The x with the I is each individual data point. So you're taking the difference between each individual data point and the average, you're squaring that. That funny symbol, sigma, basically means that you add it all up. You add up all those values, all those differences between your data points and the average, and then you divide it by n minus 1, which means how many data points you have minus 1. The minus 1 is just simply a little correction. I won't go into why it's a correction. And then you take the square root of that value, and that's your standard deviation. Now to get the value of standard deviation we want to create our artificial data, you want to find out what the standard deviation is of the GISS data around the trend line. That means treating the trend line as a moving average. So we'll just detrend the data using some magic effects right here. There we go, nice and detrended. And now we can use the data here to calculate the standard deviation we want to create artificial data. Now we create some random, normally distributed data with an average of 0 and the standard deviation we just obtained, which can easily be done in Excel. I'll leave the formulas in the description bar for you. For those of you who don't know what a normal distribution is, there it is on the screen right now. That's 3 normal distributions, all with an average of 0 but different standard deviations. Now the best way to think about these curves is to think about the kids game pinning the tail on the donkey. If you were to randomly place a point under the red curve, you've got a much greater chance of being close to 0, which is your average, than you have of being close to 3 on the x-axis, and you've got virtually no chance of being close to 8. Now as you compare that with the green curve, which has got a much larger standard deviation, then hopefully you can see how standard deviation affects the distribution of the data. Okay, so now we have that random data. All we have to do is add the trend to it from GISS, which is 0.018 degrees per year. And the important thing to remember is that there is absolutely zero doubt that this data has this trend because we made the data with that trend. So the next step is to create a century worth of artificial data, and then we count how many times a 13-year trend, which is equal to or less than the real 1998 to 2010 trend, occurs. And as you can see on the screen, the real 1998 to 2010 trend for GISS data is 0.014 degrees per year. So let's see how many times a trend lower than 0.014 degrees per year occurs in the artificial data we just created. There it is. There's 5 independent trends that are equal to or lower than, well, they're all lower than 0.014 degrees per year, which is really quite extraordinary given that you can only get a maximum of 7 13-year independent trends in a 100-year period. And I said independent trends there, and it is important to point out that these are independent trends. There is not a single data point shared between any of those 5 trends there. So that's pretty much my methodology there. In terms of sample size, I actually made 100 independent centuries of artificial data for each temperature series and counted, just as we done there, the number of trends that were lower than or equal to the real 98 to 2010 trend. And here are the results. This is the mean number of independent trends for each temperature series that we found per century, and the bars are 95% bounds, which is basically obtained by multiplying the standard deviation, remember that, by 1.96, and those bounds should encompass 95% of your data. But that is assuming that your data is normally distributed. So we'll just do a quick validation check. So there we are. I have compared the actual data we obtained, which are the blue bars, with what we would expect from a normal distribution, the red bars, and also the Poisson distribution. That's Poisson as in French fish, yes. The Poisson distribution is just one that is typically used to analyse count data of rare occurrences, sort of like what we have here. And as you can see, the GISS data and the UAH data fit the normal distribution pretty damn well. I'm happy with that. The RSS data deviates from the normal distribution slightly. It's not a huge problem, I don't think. The 95% bounds are still rather informative in that case. But the real odd one out is the HAD crew data. It doesn't really fit the normal distribution at all, but it's damn near identical to Poisson. But even just looking at that, you can see that over 10% of centuries will have 2 trends that at least match the 1998 trend, and about 34% of centuries will have 1 trend that at least matches the 1998 trend there. I'm running out of time now, but I hope I've at least shown that the trend since 1998 in the temperature records isn't really that uncommon, and I hope this has been an informative video and you've enjoyed it. Thank you for watching.